Why do most fossil fuels come from the Carboniferous period?
Why do most fossil fuels come from the Carboniferous is only sort of true if you're talking about coal. While an older reference, Boys et al., 1982 provides a great synthesis of ages of deposition formation of coal, petroleum, and methane natural gas.
In detail, the production rate of coal was the highest during the late Carboniferous, but production rates during the Permian were almost as high, and in general, the rates of coal formation during the Jurassic, Cretaceous, and early Cenozoic were still moderately high. So while for coal it's fair to say that a large amount formed during the Carboniferous, it might be a stretch to say most.
In terms of older coal, there is a relatively small amount during the early Carboniferous and Devonian, but beyond that you start to run into a few issues, namely that land plants, which are the source organic material for coal, were not particularly abundant or were totally absent prior to the Carboniferous, i.e., the primary colonization of land by plants took place during the Devonian. If instead we're interested in petroleum, the Carboniferous and Permian were not particularly productive.
Instead, the vast majority of petroleum was produced during the Cretaceous and late Cenozoic if we're mostly talking conventional oil, or Cretaceous and early Cenozoic if we want to bring in unconventional resources, i.e., tide oil, tar sands, etc. Is it a matter of it just taking that long, or could there also be older or younger coal beds? I'll interpret your question more in terms of why certain periods produce more hydrocarbons than other.
The short and generic answer is that it reflects the right tectonic and climatic conditions for large and geologically long-lived areas of the right kind of primary production, i.e., terrestrial plants for coal, marine photosynthetic microorganisms like algae for petroleum to persist, for that organic material to be deposited in such a way that it was not significantly decomposed before being buried, and then underwent the right burial thermal history for that organic material to be converted into the hydrocarbon of interest.
For some examples, let's first consider the late Carboniferous for coal. As discussed by Nelson et al., 2016, the high production rate of coal during the Carboniferous is primarily a function of paleogeography and paleoclimate. Specifically, coal swamps of the Carboniferous produced vast amounts of coal because they were 1. Geographically extensive and 2. Persisted for a while geologically, in large part driven by the paleoclimate of Pangaea.
Of note, there is an oft-repeated claim that the rate of coal formation during the Carboniferous was extremely high because organisms that could digest lignin had not evolved yet, but this is demonstrably false. This idea derived from a paper in the early 90s, Robinson, 1990, but has been shown to be incorrect by multiple papers, one of the primary ones being the previously cited Nelson paper.
Paleoclimate and paleogeography, both linked to tectonics, similarly explain why the Cretaceous was an extremely productive time for petroleum formation. Generally, much of the Cretaceous was extremely warm and sea level was very high. This led to large swaths of shallow and warm seas like those that characterized much of what is now the Middle East, which were perfect for vast amounts of primary production by marine photosynthetic organisms.
For both examples, it's not just enough that there were large amount of organic material produced and deposited, but it also had to experience the right burial history. These organics need to be cooked at the right temperature. If they don't get hot enough, the chemical reactions that form coal or petroleum won't occur. If they get too hot, the organics will effectively break down. For example, for petroleum, they'll start to thermally crack. 28 Chemistry 29 Thermal cracking.
The material reaching the right temperature range again is largely driven by the tectonic evolution of particular areas after deposition, where the right amount of burial brings the buried organic material to the right depth and keeps it there for long enough, and thus the right temperature to convert the original organic material into coal. Petroleum, for example, Angula Vargas, 2022.